Hello 112 students. Based on what I saw in your mud cards, it seemed there was still a bit of confusion about solutions and saturation, so that's what this video is designed to address. So we'll talk about how solutions form, we'll talk about unsaturation, saturation, and supersaturation. Let's get started. Before you actually make a solution, your beaker is going to look something like this. We'll have a lump of pure solute down at the bottom, surrounded by a big mass of pure solvent above it. We've got just solute-solute and solvent-solvent interactions going on. What we need to do is break both of these up so that we can form those solute-solvent interactions that we want. So you can see here we've gone from having two pure substances in the beaker to having one mixture in the beaker, because now the solute and the solvent molecules are interacting with each other rather than just themselves. It is important to note that this process may be endothermic or exothermic, depending on the strength of the interactions. And this occurs because the forming of solutions is a process largely driven by an entropy or a disorder increase. We'll talk a little bit more about that in Chapter 12 on thermodynamics. Let's take a look at saturation. So a saturated solution contains the maximum possible amount of solute that the solvent can hold. An unsaturated solution contains less than this maximum amount. Let's consider two beakers. We're going to define saturation at this temperature as 3 solvent molecules for every 1 solute molecule. So if we take a look, both of these have the same number of solvent molecules, 18. Under the saturated condition, all 18 are taken up by having interactions with solute molecules. This is saturated. It can't hold any more. But if we take some of these away, like this beaker where we only have 3 solute molecules, this means that we have 9 solvent molecules that aren't interacting with solute. This is unsaturation. But please take note that I said saturation at this temperature. The saturation condition depends on the temperature of the solution. Let's consider that. For solid solutes, solubility increases with increasing temperature. This is because fewer solute-solvent interactions are needed to stabilize the system. Let's consider two beakers. Both beakers will have 20 solvent molecules each. At a low temperature, saturation is 4 solvent molecules per solute, but at high temperature, it's only 2 solvent molecules per solute. Let's add some solute to these systems. If we saturate this system at low temperature, that 4-to-1 ratio means that this can only hold 5 solute molecules. But what if we increase the temperature? When we go to that higher temperature condition, we only need 2 solvent molecules now for every solute, which means that saturated, it can hold 10 solute molecules. So to recap, lower temperatures, you'll have fewer solute molecules at saturation than you will at a high temperature. But what if we took this hot solution and we cooled it down? This is how we get supersaturated solutions. You make a solution at high temperature when it can hold more solute, and then you cool it very carefully. That extra solute is what causes the supersaturation. Now, a key thing to remember about supersaturated solutions is they are unstable. We've cooled this back down to a point where it really would prefer to have 4 solvent molecules around each of these solutes, but because of that ratio, it can't. So let's perturb this unstable system. If we take one more solute molecule and we drop it in there, it's going to cause a chain reaction of events called precipitation. What's going to happen is the solute and solvent molecules are going to rearrange themselves so that you get that 4-to-1 ratio again, and that's going to leave some solute out. After this reshuffling has occurred, we've got new 4 solvent molecule clusters around solute, and that extra solute has precipitated out, become solid again in a lump at the bottom of the beaker. We now again have just a saturated system. We have a mixture, so a homogeneous mixture solution saturated on top, and a lump of undissolved solute way down at the bottom. So, I hope that this cleared up a few questions that you might have. If it did not, please come see me in my office hours. I would love to see you. Or hit up a study pod. They are really good at explaining these sorts of things. Regardless, I will see you guys again next class.